Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have very interesting, tricky, I would say like a relaxing algebra question. So we need to find out which number is larger. On the left side we have 1.01 to the power 10, or on the right side we have 2. So right now you can easily test your intuition, test your school knowledge, test your algebra skills, and write your assumption down into the comment section which one is larger, on the left side or on the right side. And of course in a few minutes we will check our answer. So the first way and the basic one, but to be honest I don't recommend you that approach. A lot of students might be thinking, okay, let's just raise 1.01 to the power 10 with the basic method. We have power, so it means that we need to multiply 1.01 times 1.01 and times 1.01. You know this basic method, when we raise this expression by each other, we raise 10 times. I don't recommend you this method because this is a long method, so just forget a little bit about it. I don't recommend you this one. I'm going to show you a really interesting approach which is called like binomial expansion. First of all, on the left side, let's write this 1.01 to the power 10. So 1.01 to the power 10. We can write, instead of this 1.01, we can write 1 plus 0.01, and of course we need to raise this to the power 10. So we change nothing, we just write, instead of this 1.01, we just write a thumb, 1 plus 0.01. And right now there is the formula which is called like binomial expansion formula. How does this formula looks like? I'm going to write this formula right here on the left side. So whenever we have 1 plus x raised to the power n, this is equal to 1 plus n times x, so linear expansion right here, plus n times n minus 1 over 2 factorial times x squared. Okay, these are a quadratic approximation, and of course I'm going to write our third term approximation. This should be enough for a good approximation. So plus n times n minus 1 times n minus 2 over 3 factorial and times our x cube. And of course we can easily have like we can easily find our fourth power approximation just for better accuracy. Okay, but in our case let's find our third term expansion. This should be enough for a good approximation, and from here we can easily say, okay, our x equal to 0.01. let's write it, for example, let's write it right here. So x equal to 0.01, and our n is equal to 10. Okay, our n is equal to 10. This is our main thing that we really need to apply our formula. So right now let's find our value. So 1 plus 0.01, so we have 1 plus 0.01 to the power 10 equal to this expression. But first of all, let's find our linear approximation, so our first term. Okay, so our first term is equal to 1. This is our first term, is equal to 1. Our second term, this is our n times x. This is our second term. Let's find it. N times x, so our n equal to 1. Our n equal to 10. Sorry, yeah, we have right here 10 times 0.01. 0.01. When we multiply it, we have 0.1. This is our second term. This term. Right now, let's find our third term. This is our third term. Third term. Okay, as a result, when we plug in 10 right here, we have 10 times 10 minus 1 equal to 9, so we have 90 over, right here we have 2 factorial equal to 2, and times x squared equal to 0.01 to the power 2, so we just multiply this 0.01 by each other. As a result, we have 0.0001, and as a result we have 90 over 2 equal to 45, and times 0.0001 equal to, when we multiply it, we have 0.0045. So this is our third term. This is our first, let's write it, let's underline it, first term. This is our second term. This is our third term, and of course for better accuracy let's find our fourth term. This is our fourth term. So let's underline it as a fourth term, and let's find it right here. So our fourth term, term. As a result, what do we have? We have 10. We have 10 times 9 and times 8. We're going to divide it by, right here we have 3 factorial, we're going to divide it by 6, and we're going to multiply it by 0.1 to the power 3. So 0.1 to the power 3. What do we have right here? 10 times 9 times 8 equal to 720, over, we have right here 6, and times, when we raise this 0.1 to the power 3, we're going to have 0.0000. So how much zeros do we have? 1, 2, 3, 4, 5, I guess. Yeah, 5 zeros and 1. And right now let's multiply it. We're going to have right here, when we divide it, we have 120 times this expression with the zeros. So we're gonna rewrite it right here. So 0.1234 and times 1. And when we multiply it, we're gonna move this dot to the right side. So as a result, we have 0, 0, 0, 0, and 12. So these are our fours. These are our four terms. So right now, let's plug in each of these terms into this formula. So as you can see right here, we have our binomial formula equal to this thing. But in our case, we plug in the value that we need to plug in from here. So as a result, 1 plus 0.01 to the power 10. Let's rewrite it right here. So 1 plus 0.01 to the power 10 is equal to, so as you can see right here, we're going to add 1, so we have 1, plus we have right here a second term equal to 0.1, the third term right here, we find it equal to 0.0045, equal to plus 0.0045, and plus, for better accuracy, let's find our fourth term. Fourth term is right here, equal to 0.000 and 12. So plus 0.000 and 12. And when we add all of this stuff, as a result, our approximately value of these parentheses, when we add all of this, we have 1.104 and 6 and 6 2. So let's make a real quick conclusion. So first of all, let's rewrite our question from the beginning. So we have 1.01 to the power 10, and we have 2 on the right. This is our question from the beginning, but right now we can easily say that this expression is approximately equal to 1.104462. So this expression on the left side is approximately equal, so this expression is approximately equal to 1.10462. So this expression is approximately equal to 1.10462, and of course we have 2 on the right side. So this expression on the left side is significantly less than 2. Okay, this expression is significantly less than 2, and it means that if this expression is approximately equal to this one on the top, that it means that this expression on the top is less than 2. So this expression is significantly less than 2. And why expanding to a third term is enough? It's an infinite sum, but when x is small, the higher power of x shrinks very fast. So each extra term is roughly x times smaller than the previous one. So it doesn't matter when we find, for example, the fifth term, sixth term, each of these terms will be significantly less than the previous one. Okay, and it means a lot. So each step is roughly 100 times smaller than the previous one. So it doesn't mean when we find the fifth term, the sixth term, it's absolutely enough for us to say that this expression on the left side is smaller than 2. And of course, 1.01 to the power 10 is significantly less than 2. So this is my method. This method is called like binomial expansion. So I really hope you understand it. If you have any question, write a question down in the comment section. It's really interesting to read about your question in the comments below. And of course, thank you for watching. And of course, a lot of students try to solve this question like that. They try to raise this 1.01 to the power 10. They just multiply 1.01 by each other a lot of times. And you know, this up to them. I don't recommend you to use this type of method because it takes a lot of time and it's not good for your teacher. Try to learn a little bit more complicated, I would say, but this is like a general method. For example, you have power 20, so it's not the way that you multiply all of this expression by each other 20 times is not the best way to solve it. But with the method, with the binomial expansion, we can easily say that with approximately answer, with approximation this, we can easily say which one is greater. And in this case, this expression on the left side is significantly less than 2. So I really hope you understand my explanation. Write your question down into the comment section, write your notes down into the comment section. It's much interesting for me to communicate, to exchange information in the comments below. And thank you everyone for your time. Wish you all the best in life. Take care of yourself and have a great day. See you in the next videos.